Please welcome Viktor.
Okay, so very quick introduction. This is how I look like. This is how I would look like 10 years ago, something like that. Anyways, I work for CloudBees. We're a company behind Jenkins, enterprise, open source, all those things. I'm one of the Docker captains. I'm very close to containers. I'm very close to Kubernetes, schedulers, apart from, of course, working with Jenkins. I have a blog, some courses, YouTube videos, books. Buy them immediately. And I have a Twitter account. I guess you didn't know that. Anyways, so before I actually start with the presentation, I'm going to actually jump forward and ask you a very quick question. No, before I ask you this question, how many of you are using containers in production? Kubernetes? What's wrong with this country? Really? Okay, so if you don't understand a thing I'm talking about, that's normal. So don't get surprised. You have still time to leave. Okay, this is going to be complicated then. So, a question. How much would it take for you guys right now if you would open your laptops to create a cluster with as many nodes as you need to make it secure, to make it scalable automatically, no manual things, to make it fault tolerant, to install all the software you need for continuous deployment, and probably quite a few other things, right? No? Okay. You're not talkative today. Excellent. So I'm going to try to show, I'm going to give you a short history of Jenkins and how we got where we started, how we got where we are, and I'm going to try to make that talk long enough for my cluster to create in a background with all those features, right? That's going to be one of my missions. So first I'm going to create a cluster. I have a tool called the JX, short for Jenkins X, I think, which I'm going to use to create a new cluster, completely new in front of you, so no cheating or anything. I'm going to use GKE. GKE is Google Kubernetes engine. And while the cluster is being created, I'm going to give you a quick introduction to where we are right now. So I'm going to use my own account in Google. I'm going to say that I allow Google to create my cluster. And I'm going to hope that wireless works today. We'll see. OK. And it asked me a couple of questions, like where do I want to create it, in which of my Google accounts. I'm going to use that one. And it will take maybe 10 seconds until the next question. And then we are all finished with it. And then it will do in the background everything it needs to do to create a cluster as it should be in 2018. So this is now awkward silence. We need to wait until this finishes. Almost there. Yeah, where are we going to run? Somewhere in Europe. Let's say West Europe. OK. Here, how big I want my servers to be. I'm going to use standard 2, which is, I think, 4 gigs of RAM or something like that. How many nodes do I want? I want 3 servers to have in my cluster. And if my load increases, I want to allow Google to scale up to 5 nodes. I'm going to leave the default values. And now it's creating a cluster. And let's see how much it will take. And it will do much more than to create a cluster, but I will explain that later. So while my cluster is being created, let me give you a story how we got where we are right now with Jenkins and Kubernetes indirectly. So a long time ago, like maybe 15 years ago, the tallest Japanese person in the world called Kosuke Kawaguchi created Hudson. Any of you know what Hudson is? Okay, so the Hudson was Jenkins at the time, right? And it was extremely successful. Within a very short period of time, it was adopted by community. Everybody started using it, not everybody, but a lot of people in companies started using it, and it became de facto standard for all, at that time, continuous integration processes in Sun. That's where Kosuke worked. That's where it all started. Now, sometime later, anybody from Oracle here? OK, then I can speak freely. A bit later, Oracle bought Sun, And Oracle did what Oracle does whenever they find something nice and decent and good, and that means crush it, destroy it. They tried to do that with Hudson, and as a result of trying to make Hudson not open source, or less open source than it was at the time, that was 2009, we got a fork. Koske and the community behind to what is today Jenkins forked Hudson and created a completely new project, which is today called Jenkins. And you know what happened with Hudson? Any of you using Hudson today? Well, that is what happened. There is no Hudson anymore. So after that, years passed, and we made quite a lot of changes to how Jenkins operates. Some of those changes are very radical. One of those is that we switched from freestyle jobs. If you're using Jenkins, you probably know what freestyle jobs are. And freestyle jobs needs to die because they're designed to allow you to create your CI/CD processes with clicking some buttons. Click button, fill in one field, fill in another field, click save, and you have a job. And that's horrible. I know that some of you might like it. You like clicking buttons, but that's not where we are as industry. That's not where we are going. We got Jenkins pipelines, which are a way to define your processes through code, because everything today needs to be a code. If you're not used to writing code, then you're in a wrong industry. And if you're seeing who know Jenkins from before, you know that it is probably most likely, almost certainly, the ugliest tool in the market. That's what Jenkins is. We made it pretty. It has nicer colors today. Like 4 years ago, I think, or maybe 5, this was all happening more than 4 years ago. 4 or 5 years ago, containers became a thing. And when I say a thing, containers, that means that containers are already used for 15 years, but most of you never even heard about containers until probably a couple of years ago. And a couple of years ago, Docker came up as a company, and they made containers easy to use. And since then, everybody, except people in Zagreb, I'm sorry for that, judging by the raised hands, started using containers because they're awesome. They're immutable, and immutable means that they're reproducible, that we can have finally, that we can say what runs on my laptop is the same as what runs on your server, and you have no excuse anymore to come back to your open bugs and say it works on my laptop. I don't know what's going on with testers. And that became a norm, and that's 4 years ago. We don't even talk about containers anymore. Containers are not used directly anymore. That's a thing of the past. That was 3 years ago or something like that. In the meantime, at approximately the same time, microservices became a thing. And it is not a coincidence that microservices became popular at more or less the same time as containers emerged, because microservices are manageable. They are easy to implement with containers. Without containers, doing microservices would be just too expensive on operational side. It might be nice for you as developers, but for operations, microservices are hell on earth. With containers, there is a surge in microservices usage. Most of the companies I speak with are planning or already moved or are moving to microservices simply because they bring us too many nice properties, right? We can have small team, I mean like 6, 7, 8 people working on a product without being tied to the rest of the company and delivering whatever they want to deliver by people working on other services or doing whatever they are doing, and many other things. And then like 3 years ago, or maybe 4, Kubernetes became a thing, and it taught us, together with other orchestrators, that we cannot manage containers directly. If you have one application, then everything I'm talking about is ridiculous. But once you start working at scale, at a really large scale, containers are unmanageable by themselves. They need a scheduler. They need somebody who is going to do the work for us, who is going to, a tool that will decide where should a container run, that will monitor those containers, rerun them if they fail, take care of memory and CPU, make sure that they have external storage, and so on and so forth. We needed a tool that will manage containers for us. And we got Mesos, Nomad, Docker Swarm, Kubernetes, they're all dead today. The only thing that is left standing after 3 years of war between all those schedulers is Kubernetes. This is the de facto standard. That's what everybody uses today. And for a very, very good reason. So we added a support for Kubernetes, meaning that all current and future development in Jenkins space is one way or another tied to Kubernetes. It is tied to containers. If you're thinking about upgrading Jenkins, you will realize that almost all the new features are related. Not all, but most of them are related containers. Again, for a very good reason, because they allow us to do things that we couldn't do before. And you will see some of those things in action very, very soon. But still, that was not enough. Just simply supporting Kubernetes was not enough. It did not provide all the benefits we wanted. And what we realized a couple of years ago, that we wanted to redefine what continuous deployment, continuous delivery means. So we came up with what we call Jenkins X, which is not just another variation of Jenkins. It is a tool that defines how you should do continuous deployment, defines the process. And which is very complicated for many to adopt today, because everybody thinks that they know how to do CD, and everybody thinks that they're better than anybody else. And then they start writing their own scripts and their own processes. And after a couple of years, they fail, and then they say, what the heck happened? So Jenkins X, you will see, but the main, I will show you in action in a minute, but the main advantage of Jenkins X is that it tells you something like, you don't know what you're doing, this is how you should do stuff. This is the process. There are not 2 processes, 3 processes, 5 processes, this is the process. And that process is very tightly tied to Kubernetes, and it is also it is based on principles of GitOps. And that means that everything that happens anywhere is always stored in Git, right? If you need to make a new release, the information about that release must be in Git. If you need to do whatever you need to do, everything needs to be in Git, and everything is based on pull requests and so on and so forth. If you're not using Git, then there is a problem that I cannot solve for you, if you're still on SVN or CVS or what else is there? Perforce. Heck. Okay, so the reason why I told you about this is to give the system time to create everything I needed. And it is halfway there. Actually, the whole process was faster than me. So now I'm going back to my, can you see this? Is this big enough? Yeah, okay. So we are back to the setup process. So it asked me, do I want to install Ingress? Ingress, since you don't know what is Kubernetes, Ingress is kind of a dynamic proxy that will auto-configure itself whenever we deploy a new application inside of a cluster. And then now you can see that it is installing Helm. Helm is a package management. If you used apt or Yum or what is it called in Windows? Chocolatey. Then Helm is equivalent of those tools, package management, just for Kubernetes. It defines, it allows us to deploy our application and manage them in a very relatively easy way. And now it is still, since it was waiting for me to answer this question, I answered. Now it is installing everything I need. You will see in the output what that is. We have approximately 1 minute until my whole cluster is ready. And when I say ready, I don't mean only created, but all the tools are there, everything is there. If you have a question, you have like 40 seconds, or you can watch me in silence. No questions? Okay, too late. It asked me what is the domain I want to use to access my cluster. I'm going to use the default, which is nip.io. You know what is nip.io. You'll probably say that you probably don't, but you will not admit it. It asked me, do I want to use my own GitHub? It detected that there is a GitHub username Farčić. Do I want to use it? Yes, I will use my own GitHub username. It is asking me whether it can pull everything that it needs to run locally on my laptop. I said yes. And now it is installing Jenkins X itself. It already finished installing Helm, which actually is called Tiller, which is a package management I mentioned. It will install Chart Museum, which is where we're going to store our definitions of our applications. It will install Nexus in case we use Java or some other language that needs to store artifacts somewhere, and it will install a couple of other things in probably like half a minute. It created also a namespace, but you don't know what namespaces are because you never used Kubernetes, and then I'm in a difficult situation. Namespaces are a way to split your cluster into subclusters so that work of one team is isolated from whatever other team is working on, and so on and so forth. It is doing stuff, right? It takes approximately, if I didn't speak too much, it takes approximately 50 minutes to have a fully operational cluster. As I said before, it auto-scales, fault tolerant, it has all the tools installed, and so on and so forth. Any other questions? No, the first question while waiting for this to finish. No? Is it too slow for you?
Does Azure or AWS have an equivalent?
Yes. Yes, you could, in Azure, it's called AKS, Azure Kubernetes Service. In AWS, it's called EKS, which is Elastic Kubernetes Service. Every major provider today has a Kubernetes as a service offering. And they're all, so the important thing to understand is that all service providers adopted Kubernetes, they see it as a future. And all software vendors, us included, also are right now, while I'm talking, working on a next release of their software that will be most likely exclusive to Kubernetes. It's not even a choice. You don't have a choice anymore whether you want to adopt Kubernetes or no. You can either choose not to upgrade or to go to Kubernetes, whatever you're using. That's the state of the software industry today. There are a few exceptions. Oracle. Actually, they are not even an exception. Even they adopted Kubernetes. And my reference was that something is mature and adopted by everyone. If Oracle says it's okay, and they're always last, that means that it must be already used by everybody else. So, any other question while waiting? This is too slow. No? Okay, watch the screen. Okay, we're moving. It is waiting for Jenkins to, I think it's waiting for Jenkins to be ready. It is downloading all the images of all the software we need. Everything is a Docker image. Actually, everything is a container image. It's not necessarily Docker anymore. Even Docker as containers engine is going to fade away slowly. It's going to be replaced by containerd or something else. We see that. So any other question while waiting for this to happen? This is the...
I heard a lot of talk about people using Chef and Puppet and other DevOps tools to automate and build the containers, to orchestrate all that. Is that worth the hassle?
No, that's silly. So to use Chef, Puppet, Ansible, any of the, and I'm saying that from the point I thought that I loved Ansible, and I used those tools in CF Engine, which probably most of you never even heard of. It's silly. Simply Kubernetes does the orchestration of the applications. That's it. And adding a middleman like Chef, Puppet, whatever, that doesn't bring any additional value is silly. Now, you can say, okay, so it doesn't make sense for me to deploy and manage my applications with Chef, Puppet, but I can use them to create a cluster. Right? That might be a reasonable assumption. But that is silly as well, because first of all, those tools are built to support on-prem setups. And if you want to use something to orchestrate something in 2018, you probably would switch to Terraform or Packer. And second, actually the better tool would be to use shell script, because your clusters don't need anything anymore. They just need a container engine and maybe two more things. It's not anymore that we need servers that need to have 2,000 things. No, we just need a container engine. That's about it, more or less. Kubelet. So 2 binaries. For 2 binaries, I don't need Chef, Puppet, or anything like that. And if I do, then Terraform is your friend. Okay, almost done. It is creating my repository. You can see here that it is creating a repository called something staging. Because as I said before, it uses GitOps principles, meaning that if I want to deploy to a staging environment, it needs to be stored in Git, because it needs to be recorded. And it already created a repository for me for staging. And if you look up there, you cannot see it anymore. It passed. It also created a repository for me for production. So at the moment, I set it up to have two environments to deploy to. One is staging, one is production. Both of them got their repositories, in this case in GitHub, and everything will be recorded and everything will be handled through pull requests. And I got a password for my newly installed Jenkins. I'm going to store that in environment variable for later. Okay, so now let's say that we have a whole system, we have a whole cluster that is capable of handling our to do everything we need with our applications, the whole life cycle. So the first step would be, let's create an application. Let's create our first application that we're going to simulate as if this is that I'm developer right now, and I'm going to say, okay, I want to create my first application. I'm going to say JX create quick start. It asks me, okay, what is the type of application you want to create? And this is extendable, right? You can extend it to any type of application, any type of scaffold, and I can choose one of the applications here, I don't know, Node or Python or whatever I want. Or I can skip all that and say similar command, but I already know what I want to use. I'm going to use Go because everybody is coding in Go today, right? You're coding in Go. Okay, it is. I said, okay, I'm going to create a new application in Go. It asked me what is the name of the application. I'm going to leave the default, Golang HTTP. And it asked me, do you want to use your own Git to store the application? It needs a repository and anything else. I'm going to say yes. Do you want to initialize your repository? Yes. What is going to be the message of your first commit? The first commit is creating a scaffold of application, right? I'm going to use the default value. And now it created a third repository. It didn't yet, but it will soon. For my application, what is my user in GitHub? Sorry, what is my organization? I'm going to use Viktor Farčić and the repository name. And now it created the repository with all the files I need, everything I need for my application to have a very quick start working with it. And this is the address, you can see it here, up there somewhere is the address of the GitHub repository, and it did a couple of other things that I'm going to show you soon. So first of all, let's confirm that really my application is available locally for me to code. Here is my application. It has everything I need. It has Docker file to build images, Jenkins file to run continuous delivery process, make file, charts. There is my main Go function, scaffold. It has everything it needs, and it's already in my GitHub repository. Just to prove to you that it really created a GitHub GitHub repository. This is my GitHub repository. You can see by the time I'm not cheating. This was created a minute ago. It's already there in GitHub, and it's waiting for me to make the second commit, if I choose to do so. I'm going to quickly show you the files. I'm not going to go in details, but you can see here is the Docker file. It defines, it's very simple because Go doesn't need much. Everything it needs to build my images. There is Jenkins file that contains everything that we need for a complete process from a commit to deploying it to production. It has my charts, which again, since you're not familiar with Kubernetes, is the way to package my applications for Kubernetes. And it has two directories, Golang HTTP and Preview. Golang HTTP is going to be my production version. Preview is what's going to allow my testers to test my application. Now, I don't think that anybody should test an application manually, but if you do, and most of you do, then that's how you do it. And it did a couple of other things. Because every commit should notify Jenkins. If you use Jenkins or any other tool, you know that you should create a webhook in your GitHub repository that should notify your tool that there is a new commit, so that tool, in this case, Jenkins, can do whatever it needs to do. And even that was created already for me. And this was created a minute ago. it's already configured, GitHub is already configured to notify Jenkins whenever there is a new commit, wherever Jenkins is. And it also, while I'm talking about it, the first pipeline is already running. It made the first commit, and my build is already running. It's running tests, it's running building, it's going to deploy to staging, and it's going to do everything it needs to do, and that is happening in the background already. But before I get there, before I show you what's going on right now, I want to show you quickly this repository in GitHub. This is the repository of all the projects that are currently supported out of the box. So whatever is your programming language, it might be here. Like this is the Golang I use. And you can extend those things. So you can create your own scaffold, your own bootstrap, based on one of those, because it's easier than starting from scratch. Well, if your application is not already supported, or sorry, programming language is not supported, or if you want something to happen a bit different than what comes out of the box. So all you need to do is to just make a pull request, or to tell Jenkins X to not to use this repository, to use whatever is your repository, wherever it is. And you can also skip GitHub itself because you think that GitHub is silly, and you can have it locally as well, and you see those files locally on my laptop are the options I used at the very beginning when I created the application to choose the language or the type of the application I use. So now, while we're talking about, let me show you the pods. Pods in Kubernetes are the minimum, smallest units of deployment. Everything is running as a pod, and pod is one or more containers in running in a cluster. And you can see that already all those things that you see here, those were either created when cluster was created, or were created by my first pipeline, my first for the application I run there. And you can see there's Jenkins, there's Chat Museum, where we store charts, Helm charts, some controllers, Docker registry to store Docker images, Hipster for monitoring CPU and memory, MongoDB, that is a requirement for Monocular, which is the way to visualize charts, and Nexus, and Maven, and what's not, right? There are 2 errors, I'm going to ignore them for now. And if you wonder whether, I don't like UIs, I almost never use UIs. I think that they are silly, waste of time, but some of you do. So you can also open Jenkins itself and say Jenkins console. And I'm going to copy this password. And here you go. There's Jenkins. It's already doing something. It's not simply Jenkins. It is already configured to do everything it needs to do with my fancy Go application. And you see that there are 3 jobs already created. One is for all deployments to our production environment. The second one is for all deployments to the staging environment. And the third one is the application I just created a few minutes ago, right? And it already has a job. It already works. It's already doing whatever it needs to do. Now, as I said before, I don't like UIs. I like doing things from console because that makes me a ninja. So I can say, Jags, get activities. And I can see directly here, without going to any UI, what is going on right now in my cluster. And you can see that the deployment for production to production was successful, whatever that means. I'm going to show you. Staging was successful. And my application, Golang HTTP, that I created a moment ago on the branch master is running. The pipeline that does something with that application is now in process. It is doing something. It is running. And actually, if you look at the last status, you will see that it is running a pull request. And that pull request was made to the staging repository, where it updated that repository with the definition of my first application. I want to deploy something to staging. Commit was made to Git. Pull request was made to the master branch. And now it is doing something in a separate job for that, for the staging environment. It is deploying to my staging environment while I'm speaking about it. And if you want to be more specific, instead of getting all the activities in a cluster, you can say, okay, I want to get activities only for a specific application. And the name of the application is Golang HTTP. I'm going to put -w to watch the progress. And now if you like sitting in front of the screen and watching things going on, you can do that. And you can see that at the moment it is running the pull request, or the process behind the pull request to the staging environment. Now, again, if you wanna, let's say that something went bad, or you're simply curious, you can also get the logs. You can say, Jenkins, give me the build logs of everything happening in the cluster, no matter where, no matter what. And not much is happening, but it will ask you, okay, you need to be a bit more specific. Do you want to see logs of the master, of the production environment, or the staging environment, or do you want to see logs of your application? Or you can ditch all that and be very specific from the start and say almost the same command, but I want to see the logs for my Golang HTTP application. And these are now the same logs that you would normally see in if you go to Jenkins UI and check the logs of a specific build. Those are the logs. This is what is happening, or what was happening a moment ago. Or you can be even more specific and say, don't give me the logs of my application, give me the logs of my application on a specific branch, which in this case is master, and you get the more or less, in this case, the same result. So, okay, what are the pipelines we have? Pipelines are the processes running or that were running, and we can say, Jags, get pipelines. Show me which pipelines do you have right now in your system, and you can see all the 3 pipelines, the 3 jobs that you saw from the UI a moment ago, staging, production, and the application itself. Or you can do a couple of more things, like I'm going to showing you just a few of them. Show me all the applications in my cluster, and you can see that there is only one application, and that is Golang HTTP release 0.1. 1 out of 1 pods are already running, so my staging is already up and running, and it is available for testing or manual, automated, or whatever. And that is the last one. This is the address through which I could access my my application. This is a proof that my application is really running in a staging environment. This is the hello world output of my complicated application that I deployed a moment ago. And there is even more. Of course, the stage, since I deployed the staging, that means that I surely created the release, right? You don't deploy anything anywhere without a release. You need to know what's going on. And that release is also already created for me while I'm talking about in GitHub. And you can see that this is release 0.1. There is a source code, there is assets, and there is the list of changelog. Not much happened, but changelog of that specific release. So I'm going to switch now to the staging environment in Kubernetes to show you only the resources running in staging. And if I say kubectl get all what is now running in my staging environment, in my staging subcluster namespace, and these are the resources of my application that is already deployed to staging. There is a replica set that is making sure that it is scaling up and down. There is a deployment that is doing rolling updates so that new releases are deployed without any downtime. Replica service that allows other applications to communicate with this application. Pod, which is the container itself, and probably a few other things all happening there and all already deployed. And I can show you those environments also by doing JXNS. These are the environments that I have right now. JX is for Jenkins itself, production, staging, and kubepublic and kubesystem are coming by default in Kubernetes. So I'm going to switch to production and see, apart from running my application in a staging environment, do I run anything in production? And the answer is very simple, no. I'm not running anything in production yet. Because when I created my project, I was too quick, you didn't see it, but what I specify is that it should be deployed to staging environment automatically without me interacting with it. But for production, there will be a pull request, and there is a pull request that requires manual human intervention to say, I accept this pull request. I accept. It's a single button for the whole process, only one. It says, yes, I want to go to production. I'm confident with my tests and what's or not in the staging environment. So what we are going to do now is first we're going to see which applications are running in my staging environment. There is only one. and I'm going to say, I want to promote. Imagine that we moved forward in time, we run our tests and all those things, and I want to promote my application from staging to production, right? Everything is happening in the same cluster, but I want to do that, so I'm going to say, let's say that imagine that I review the pull request as I should have and all those things and say it's okay, it passed all the tests and it's on a cube and what's not. So I'm going to say, JX, I want you to promote the application called Golang HTTP version 001, and I want you to move that from staging to production. It is ready for my final users. And now, Jenkins X is running yet another job that you don't see in the background, that is doing whatever it needs to do to move things, to not just simply deploy, but probably test, run another round of tests in production, and so on and so forth. And you can see that because the first action it's going to do, remember the GitOps principles, before it does all those things, it's asking me, do you really, do you want to make a new commit to the production repository? Because everything needs to be stored in Git. And I'm going to say, yes, I want you to create a pull request in the production, and then it failed. Okay, let's try again. Let's try again. Yes, I do. It created a second pull request. Don't ask me why it failed the first time and it... No, now it's working. Now it's working. And soon it will process the pull request. And it will, but the fact that when I said promote, actually what I did is effectively something similar to saying merge pull request. Let me actually go to GitHub and see what's going on. This is my pull request in GitHub. And I'm going to merge it myself. I don't know why it didn't work. Things happen when you do live demos. So I merged it myself. And it detected that I accepted a pull request, merged it, and now it is running in Jenkins. And I think that we should see the status here. No, not yet. So it will take a minute until it processes that pull request and it deploys it to production. Any questions while waiting? You have like 20 seconds. No? No questions? Are you completely confused? I'm not watching you even while I'm asking that question. I don't want to know the answer. What? Yes, it will tag it, and it will create another another release in that specific branch. Because if you go here, if I go to my GitHub account, if I go to my repositories, this is the production one, and you see that there are 3 branches. Those are the branches created for the where it was committed, pushed, and then it was made a pull request. And this is the pull request. And at one moment it will finish. Actually, here you can see that if you notice for a split of a second, it was yellow because it was doing the checks. It was running Jenkins job. And when I opened it, that second moment later, it switched to green. That means that actually Jenkins finished doing whatever it needs to do. Actually, it didn't finish everything. It finished part of the work, at least part related to this pull request. And then the last thing I want to show you is to show you that everything is running. That will take a minute. I can show you that later. I try to be very quick, and you have now time for questions. I'm not sure, most likely. I don't use GitLab much myself, but most likely it does. Google it later. If it doesn't, it will. Because I know that it was on a roadmap last time I checked like a year ago, or half a year ago. It was on a roadmap to support all major ones, meaning that GitHub, GitLab, and Bitbucket, or whatever it's called from Atlassian. I would say yes, but I'm not 100% sure. Basically, it supports Git. Any other questions? That's it. I have no more slides. I have no more commands. You need to ask questions. Yes, it's free. Yes, I don't know, those of you coming last year and year before that, and then or any other talks that you saw me, I never speak about commercial stuff unless I'm with the customer directly speaking. So you will never hear from me talking about anything not free. And my marketing department is not happy about that, but yes, it is free. Actually, Jenkins X was probably it was one of the most well-received and most popular talks in the last KubeCon, which is kind of mecca for Kubernetes. Any other question? You know, I always leave enough time for questions, but that doesn't work here. Want me to dance? If you, yes. Any application, doesn't really matter. Any application that you're going to deploy to Kubernetes, of course. So Kubernetes is a prerequisite. But apart from that, doesn't matter which application you use. It really doesn't matter. Because there is a process, and process is based on GitOps and blah, 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 blah. Now, you can really find nothing prevents you from going to Jenkins file and saying, no, I want to add those things or that thing and stuff like that. It's very generic. It fits in most use cases. You might need to tweak it a bit, but that's about it. It doesn't really matter what is the type of application. Unless it's the application that you deliver on floppy disks or something, mainframe, I don't know. Anybody else? And while I'm talking change, now you see that merge status. Actually, what I showed you before was the, I think, I don't know. Anyway, it's still doing something. No? You never use Kubernetes, so this must look like magic or something like that. Anybody else? Yes, please. To learn Kubernetes, there are very good books you should buy immediately. Me. By the way, it finished, and you can see that this is my production environment. Now it is running in production. My users can access it and all those things. Yeah, books. The best source of Kubernetes is when you go to the last slide of the presentation. Any other questions? I have 2 minutes. You have 2 minutes to watch me in silence or... Last year, I couldn't finish on time because there were too many questions. What changed since then? It's morning. Ah, okay, okay. Yeah, and you had gin tonic in between or something like that. Okay, okay. So next year I'm not coming to the morning session. Last session works better. Okay, thank you very much.